Hey everyone, I'm Nick Raboy. I'm a developer advocate at MongoDB, and I'm also the organizer of the Tracy Developer Meetup. Recently, we did have a meeting at the Tracy Developer Meetup group on Unity and MongoDB. I didn't record that session, but I did want to go back and actually do it again because I think it's worthwhile material to include on YouTube, and it seemed like it had a lot of traction. So I want to make sure that everyone's successful if they were to go back and try to attempt this project on their own. So I will be using Unity. I will be using MongoDB, and we're going to be using a little C# here and there in between. If you are not already a member of the Tracy Developer Meetup and you are in the Tracy, California area, so Stockton, Lathrop, Galt, things like that, with wherever is a reasonable distance, I encourage you to register to the group, participate in our meetings. You're going to learn a whole lot. So on my screen, you'll notice that I do have the Unity Hub open. What we're going to do is we're going to go ahead and create a new project. And for that new project, I'm going to use the 2D template. Everything that I go over today, you should be able to go through either 2D or 3D. It's really up to you. 2D is kind of my jam. So that's why we're choosing it. It's I'm from the 90s, so that's where I'm going to stick. But it's totally up to you on what you want to choose. I'm going to save my project to the desktop, and I'm going to call this Tracy Devs Sample. And I'm going to say Create Project. Now, it may take a few minutes to create this project depending on what kind of computer you're developing on and the specs of that computer. All right, so you'll notice that I do have a blank Unity project open. It has a sample scene as well as a main camera. All of these are game objects. Well, at least the main camera is. So the main camera is a game object that exists within the sample scene. The main camera is just a game object, but it does have the camera component attached. So you'll notice that as we add game objects to our game, we're going to be adding various components to them that will help define, well, are they a sprite? Are they a camera? Are they something else? So that's how you define what a game object is within Unity. What you see on the screen here in this box, this is the range of the camera. So if I were to hit that play button, it would basically just zoom in on those boundaries, and we have a blank blue screen, which is pretty much normal when it comes to Unity if you have nothing in it. So I'm going to stop the previewer, and I'm going to right click within the sample scene, and I'm going to say 2D game object or 2D object. I'm going to click on sprites, and I'm going to click on square. There are other ways to create a sprite in Unity. You can create the game object as an empty game object, and you can add the components one by one. It's totally up to you. You'll notice on the right, it added a sprite renderer. In this case, the sprite is a square. I could very easily change that to an image, but the focus of this particular video, or what happened at this particular meetup, was not on the graphic side of things, not on the animating side of things. It's more on the logic side of things. So we're going to leave it as a square. I'm going to rename this from square to player, as you'll notice in the top left of my Unity editor. The name does not truly matter. It has no impact whatsoever on the game. It's just for naming purposes, so that way we know what we're attempting to work with. So I've named it player. What I'm also going to do is I'm just going to create another game object. So I'm going to create another sprite. I'm going to right click in the menu, and I'm going to say 2D object, sprites, and I'm going to add one more square. Just so that way we can see that they're not just one object. I moved the new sprite over to the right a little bit. It is white. What I'm also going to do is I'm going to change the scale of it so that way it's smaller. I'm going to cut it in half. We're not working with the Z axis much or at all in this particular example because we are creating a 2D game. So I'm going to leave that alone. It doesn't need to be touched. I'm going to change the color of this square. So this square, I'm going to say maybe it's green. And I'm going to give it a new name. So instead of just calling it square, which isn't really helpful, I'm going to call it incentive. Now, when I say incentive, think about it in a game as maybe a coin or a medal or some kind of trophy, something that your player is trying to obtain. All right, so I have a player and I have an incentive. If I were to hit that run button, it would zoom in a little bit, but I cannot actually control my player, and my incentive doesn't actually move That could easily be an obstacle rather than an incentive too. It doesn't really matter. But right now, everything is static within the scene. All right, so let's go ahead and add movement to our player. What we're going to do is we're going to go to the Assets section of our Unity editor, and I'm going to click Create. So I'm going to right click and click Create. I'm going to say Create Folder. If we truly absolutely wanted to, we can add all of our assets to the root of this Assets section. But trust me when I say this, it will get very messy very quickly if you don't start creating subfolders for all of your different components. So this particular subfolder is going to be called Scripts. It's going to include all of the scripts that are going to control our game. I'm going to double click on that scripts directory. I'm going to right click and I'm going to say Create. And I'm going to create a C# script. So this C# script is going to exist in the scripts directory. And I'm going to call this Player. The name does not truly matter. I'm just calling it Player because I know that this particular player script is going to control our player game object. It could very easily be named Joe or Jane or whatever you wanted to call it. It doesn't really matter what you call your game object or your script. All right, so we have a player script. What I'm going to do is I'm going to double click on it. And if you've already set up a default editor on your computer, in my case, I'm using Visual Studio Code, it should open up in that editor. And it'll look something like this. So every single script that you create in Unity will extend the mono behavior, and the mono behavior does have access to various lifecycle events, for example, start and update. So the start event is triggered on the first frame of your game, and the update is every single frame, and that could be variable depending on the frame rate of your device. So of course, slower devices will have less frames per second, and faster devices will have much more. We're going to see how to accommodate that in just a moment. There are other lifecycle events. So for example, there is an awake that we're going to be using in the future of this particular example, which happens before the first frame. There are other lifecycle events as well. I totally recommend that you check out the Unity documentation if you want to learn more about those. So we have our player. Our goal here is to move it around. But the first thing that we want to do is when it starts, let's define a starting position on the screen. So what I'm going to say is transform. So just by saying transform, I'm talking about whatever this script is attached to. Right now, this script is attached to nothing, but when we attach it to a game object, the transform will transform that particular game object. I'm going to say position equals new vector 2, since we're in the 2D space, and I'm going to give it a 0.0f because this is a floating point position, and 0.0f. So we're going to center this on the screen when our game loads. In the update, this is where we're going to handle our movement, and this is going to evolve as we progress through this particular example, but for now we're keeping it the bare minimum. So what we're going to do is we're going to say if, we're going to say input.getKey, and we're going to check to see the key that was pressed. We're going to say key code, and what we're looking for in this particular example are the arrow keys. There are other ways and even potentially better ways to handle user input in your game, but because this is a very basic example and this works particularly well, we're going to say, for example, left arrow, and we're going to track the keyboard presses directly. If you were working with a game controller or some other kind of input device, you may want to evaluate some of the other offerings that Unity offers. So if the key that was pressed was the arrow key, the left arrow in particular, I'm going to say transform, and I'm going to say position. I'm going to say plus equals, and this is where things can get a little weird just for now. So even though that we are working with a 2D game object, we still are in the 3D space technically, and because we're transforming just the position of the game object, which really has no kind of details on or knowledge that we're in the 2D space, what we can do is we can say vector 3, and we can say left. There are other ways to manipulate the vector position in Unity, and there are other ways to handle movement in Unity. So you don't even have to do a transform, and in a lot of circumstances, it doesn't even make sense to do a transform. But for this example, it does. I'm going to close this off for now. So this tells us that we're going to change our vector direction into the left direction. Although if we were to try this and hit the left arrow, it likely wouldn't do anything. What we have to do is we have to define how fast this particular game object should move in the left direction, and we also have to accommodate for the time speed. So starting with the movement speed, I'm just going to go up to the top of my class outside of the functions, and I'm going to create a new variable. What I'm going to do is I'm going to create this as a serialized field. So when I say serialized field, what that does, it allows us to access this variable directly within the Unity editor. And you'll see what I mean in just a moment. But what I'm going to say is private float, and I'm going to say movement speed. I'm going to default this movement speed to 5.0. And this is not a string, 5.0f. And we're going to adjust it in just a moment, but if I drop down back into our update, I'm going to say times, and I'm going to say movement speed. If I left it as is, technically it would move left, but it probably would move pretty quickly depending on the device that you're using. So in order to have a consistent experience between devices, what you should probably do is you should multiply it again by time.delta time. So I'm going to go back into my Unity editor for now. We're going to come back into the script in just a minute, but I'm going to go into the Unity editor. It's going to take a moment to reload. If I were to run, nothing would happen. So nothing happens because this script in particular isn't attached to anything. So I'm going to click on my game object for player, and I'm going to drag this script over into the components area of the inspector. And I'm going to drop it. If I wanted to, I can click add component and search for the script manually, but trust me when I say this, it's a lot easier just to drag and drop. You'll notice that movement speed is showing up because we did make it a serialized field. If I had left it as a private variable and I removed serialized field, this particular field would not exist inside of the inspector. I'd still be able to access it and use it within the script, but just not from the inspector. If I made it public without the serialized field, it would still show up. But for this particular example, we don't need it to be a public field, so we should probably keep it private. So I'm going to save it, and I'm going to hit run. Now when I hit the left arrow key, you'll notice that it moves left. When I hit the other arrow keys, nothing happens because I didn't program anything to accommodate that. So I'm going to stop this, and I'm going to go back into my code editor, and I'm going to continue to finish this. So I'm going to copy, and I'm going to say else, and just paste that in, and I'm going to do it a few times before I make adjustments. So I potentially have each of the arrow keys. I'm going to change this rather left arrow. I'm going to say right arrow. Instead of up arrow or left arrow, I'm going to say up arrow. Vector 3 up. And finally, I'm going to say down arrow. Once again, there are plenty of other ways to handle movement of your player within Unity. And once again, this may not be the best way to do it depending on what your game is going to be. So I'm going to save it. We're just going to test and make sure that it actually works correctly. I'm going to go back into Unity. And I'm going to hit run. Now I'm going to move my player around. Everything looks to be good. If I wanted to test things out, this is a little trick with Unity that you can do. I'm going to click on player. I'm still in the play mode. I'm going to go over to movement speed, and I'm going to increase it to 10. Now if I go back in without having restarted my editor, it took that change. So instead of 5, it's now moving at 10. However, if I stop it, it changes it back to 5. So any change that you make while it's currently playing, it will not persist when you stop it. However, if I changed it to 10 right now and stopped it and started it and whatnot, it would still be 10. So those are just fun little facts to know if you're getting started with Unity. All right, so we have our player. If I were to move my player over our incentive, nothing would happen, which is normal. So instead, maybe what we want to do is we want to start having collision handled. So when our player collides with our incentive, maybe our incentive changes location on the screen. So let's start handling collisions. So I'm going to click on the player. I'm going to click Add Component, and I'm going to click Box Collider 2D. Now it may be hard to see, but if I click on this Edit Collider, you'll notice that I have little boxes here. This is my collision boundaries, and I can adjust them as necessary. Because we're working with a square and we're using a Box Collider 2D, it probably will be pixel perfect collision. But depending on the image that you're planning on using, you may need to make adjustments so that way collision boundaries look and feel the way that you want, because a box may not make sense for every single example. So I added a box collider on the player. I need to add a box collider on the incentive. So I'm going to add it. If I were to hit play, we still wouldn't be done. It's still not going to register our collisions. What we do need is we need to add physics to our game objects. So what I'm going to say is I'm going to say add component. I'm going to type in rigid body 2D because once again we are working with 2D. And if I were to leave the body type as dynamic, that means that we are adding gravity to this particular game object. So we've added physics and we've added gravity. If I were to hit play, our game object, it should fall right off the screen because there's nothing stopping it from falling endlessly. For this particular game, we don't need to worry about that kind of collision. We just want collision between our two objects. So what I'm going to do is I'm going to change this to kinematic, and I call it kinematic. I don't know if that's the true way to pronounce this word. It could be kinematic, but I'm going to call it kinematic. And what that's going to do is it's going to keep our collision information. It's just going to remove our physics information. And I'm going to say use full contact. So that way two kinematic objects can collide with each other. I'm going to do the same thing for the player. I'm going to add a rigid body 2D. I'm going to change the body type to kinematic. And I'm going to say that we have full contacts. So I'm going to click that little checkbox. Now if I were to hit play, it still wouldn't do anything really because we're not really tracking any collision information, or we have it, but we're not making use of it. Another thing that we're doing is now that we're using physics, we're using a rigid body, we're still transforming the game object itself, which is working for now, but in a more complex game, you may run into trouble because what you really want to do is once you have physics on a game object, you want to control that game object through the physics itself. So like I said, it's working now, but it may not be working well, so we have to make an adjustment. So if I go back into my code for the player, we're going to start on the player. Because we're using a rigid body 2D, let's go ahead and add a variable. I'm going to say private, I'm going to say rigid body 2D, and I'm going to say rigid body 2D. We're going to use our awake method to grab an instance of this, so that way we can actually play around with it. So I'm going to say void awake, and I'm going to say rb2d equals get component. So the get component function will allow you to access any component that's attached to the game object that this script in particular is attached to. And the particular component that I want to access is the rigid body 2D. Now instead of transform, what I want to say is I want to say rigid body. And I'm going to do the same thing for all of the other areas as well. So I can't just hit play because we'll get an error. When I'm working with a rigid body 2D in particular, we're no longer in the 3D space, so we can actually change this to vector 2 instead. So if I were to run this, which I will just for testing purposes, our experience should still be the same. And it is. All right, so let's go ahead and start playing around with the incentive now. And we're gonna make use of the collision inside of the incentive. So let's go ahead and create an incentive script. I'm gonna call this incentive just so that way we know what we're working with. I'm gonna open it up. It should look pretty familiar to you. What we want to do is we want to get our rigid body component. So let's go ahead and say private rigid body. We're gonna call it the same thing. And we're going to say void awake, which happens before the start method. We're going to say rigid body 2D equals get component, rigid body. And now we can make use of it. So what do we want to do? Well, when the game starts, let's randomize the position of the incentive just for the heck of it. So we're going to say rb2d dot position equals new vector 2. And let's use random range. So we're going to say random dot range. And let's go ahead and say maybe negative 4.0 and positive 4.0. And these are not in pixels. This is based on the camera space. So it's a little different. And I'll show you how to maybe check in some circumstances on how this would work. but it won't work. It won't work on all devices like this. You'll have to do other things. So we have a random starting position. The update, we're not actually going to move the incentive every frame, so we can actually remove it. And what we are going to do is we're going to check to see if there was a collision. So what we can say is we can say void on collision enter 2D. And this means that when the collision starts. So there are other collision methods. So there's on collision exit 2D where this is when the collision stops. I think there's an on collision stay 2D. So when the collision is has been in the it's been happening for more than a certain amount of time, things like that. There are other operations as well. The on collision enter 2D is good enough for us. So I'm going to say collision 2D. We don't care what was colliding with us because we only have two components right now, or two game objects. So what I'm going to do is I am just going to copy line 17, and I'm going to paste it here. And every time we collide, it's going to pick a different position. So I'm going to go back into my Unity editor, and you'll notice that we have an error. We'll get to that in just a minute to figure out what that means. What I'm going to do is I'm going to click on incentive. I'm going to drag the incentive script onto the incentive inspector area for that. I'm going to see what this error is. So random does not contain a definition for random. I probably made an error somewhere. So I'm going to go back into my code. Yeah, it's not random. It's range. So random.range. I'm going to save it. It should be good now. Looks good. So you'll notice I positioned it here. Going back to what I said about the actual positioning. So we're not using pixels here. You can use a pixel perfect camera if you want. There are options in Unity. It's out of the scope for this particular example. But if I drag this around on the screen, you'll notice at the top area of the screen here, the position changes. So with these particular camera boundaries, we have what looks to be about 10 in the X. And for the Y, we have what? 4.87 and around 5 and 5. So it's up to you on how you want to do your positioning. Like I said, it's going to be different on all devices because all devices will not have the same aspect ratio. So you'll have to accommodate that with different logic checking depending on where you want to deploy to. I'm going to hit play. Should position it somewhere random on the screen. It did down below. I'm going to move my player over the incentive, and you'll notice that it is randomly selecting positions. That's to be expected. So everything's working as we anticipated. Let's go ahead and see a nifty trick. So if you're new to Unity, let's go back to the root of our assets area, and let's create a new folder. I'm going to create a new folder. I'm going to call it prefabs. I'm going to go into the prefabs folder. And what I'm going to do is I'm going to drag my incentive game object into the prefabs folder. You'll notice that the incentive game object has now turned blue because it's a prefab now. So prefab lets you duplicate your game objects by drag and drop. And when you do that, it copies all of the components that were previously attached to that particular game object. So I'm going to drag from my prefabs back into my scene. And I now have two incentives. They're both blue. The name does not matter whatsoever. Let's go ahead and move incentive 1 over. Let's go ahead and change the color. I'm going to say that maybe this is yellow. And I'm going to say that maybe the size is going to be 0.25. And we're done actually on that one. So you'll notice if I hit play that each of these incentives behave separately from each other. So if I hit the green one moves. If I hit the yellow one moves. Because the script, even though that it was copied over with the prefab information, each of these prefabs within the scene act independently of each other. So the script does not control all game objects that it was attached to. It controls the one game object that it was attached to. So if I wanted to, I could add more incentives on the map and it would work great. A lot of times what you would want to do is you want to initialize those with code. So maybe when your game starts, you initialize, I don't know, if we use the example of bullets in a gun, maybe we initialize 50 bullets in your gun. So those could be 50 prefabs if you wanted them to be. So you can think about it that way. So just a nifty trick if you're getting started with Unity. All right, so we have our incentives, we have our player. The next step is actually going to be to view score information. Maybe we increase our score every time we collide with our incentives. So what I'm going to do is I'm going to right click in the scene area, and I'm going to go down to UI. Technically what you're supposed to do is use TextMesh Pro. In more recent games you get more features out of it, and it's supported. Just for simplicity purposes, and really it's not too much more simple than using TextMesh Pro, is I'm going to use the legacy text. If you can use TextMesh Pro, it's not going to be too far out of your way to get it set up and working. But just for simplicity purposes, I'm going to use text because we're not doing anything fancy. What I'm going to do is I'm going to call it score text. Name doesn't matter. It was added within a canvas, and there's an event system. The event system we're not using here. The canvas will be adjusted in just a moment. You'll notice that it added another box. We can't really see it in this circumstance because by default, when we add it, it uses the screen space overlay option. And there are different options when it comes to displaying your text, because maybe you're building like a 3D game and you want the text to have perspective to it when you view it on a building when you're walking around in the game. That's not what we want here. We actually just want like an overlay HUD, like if you want to show health and whatnot. So I'm going to change it from screen space overlay to screen space camera. It does give us a render camera to work with. I'm going to go into my scene and I'm going to drag my main camera into this box for render camera. It's hard to see, but it actually, now you can see the text at the bottom left. So let's go ahead and work with that text. I'm going to call it score. I'm not going to give it a score value yet. I'm going to make it bold. I'm going to change it to maybe, I don't know, 30 pixels. I'm going to center it vertically, and I'm going to make it white so that way it's a little more visible. Now you can't really see it. I have to resize the bounding box for the text. I'm going to make it nice and large. I'm going to also move it. So right now the pivot point is in the center of the screen. You don't have to mess around with the pivot information. I find I get better results when I do. So my intention is to keep the score at the top left of the screen. So the pivot I'm going to make at the top left. And you'll notice that after I did that, it changed the position X and Y information because it's going to be basing it off of that as my center point. So I'm going to move it up, and it's going to be based on that pivot point. If I were to hit play, we'd see score text, but it would be kind of meaningless now because we're not actually calculating the score. So let's get down to business on actually calculating a score. Now to do that, we are going to need a way to store our data, and this is where MongoDB comes in. And this is going to be a two-step process when it comes to actually working with our data. This first step is going to be working with our data locally, and then the second step is going to be working with sync, so that way we can sync it between devices so we can pick up exactly where we left off. So what I'm going to do is I'm going to open up the package manager for Unity, and you can actually do that by clicking on the window menu and then going to package manager for Unity. And what I'm going to do is I'm going to add it manually as a repository. So right now the Realm Unity SDK is not a part of the Unity Asset Store. So to add it, I'm going to click on the little cog icon. I'm going to say Project Settings. That's going to bring up another window for us. We're going to add a repository. I'm going to call it npm. For the URL for this repository, this is of course going to use the Node Package Manager. You don't need to have Node installed on your computer. You don't need to be familiar with Node.js. This is just where the package is going to come from. But I'm going to give it the repository URL. So it's registry.npm.js, and then the scope for this particular package is io.realm.unity. I'm going to save it. I'm going to close this window now, and I'm going to go back into my package manager. If I click on the little drop down for packages in project, I'm going to now go into my registries. My registries may not have existed before because you didn't have any registries added, but I'm going to click it, and you'll notice that I do have Realm added now. This is the version that we're going to work with for this particular example today. I'm going to click install. All right, so the package is installed. From a user perspective, it won't have any kind of impact on us whatsoever until we start using it. So what I'm going to do is I am going to go into my scripts directory. I am going to create a new script. So the first script that I'm going to do is I'm going to create a script called Realm Controller. with the purpose of this particular script controlling everything that we're going to be doing when it comes to our data in Realm. So this is MongoDB Realm. This script is going to be attached to a game object that has no graphical ability whatsoever. It's going to be an empty game object because we just want this to be a controller type. It does not need to be visible in our game. With the Realm controller selected, I am going to drag the Realm controller over into the inspector to attach it. It doesn't do anything yet. We have no logic in there. But what's going to happen is I'm going to double click on Realm controller, and we're going to get down to business. So first of all, I don't need the start and the update. We are going to leave it as a mono behavior, but we don't need to be worrying about frame information. So there's different ways to work with Realm. And there's really not a wrong way. I'm going to show you my preference. So my preference is to work with a singleton instance. So in a typical game, you're going to have more than one scene in your game. Right now, we're only working with one scene, and that's all we're ever going to work with. But if you choose to have multiple scenes in your game, every time you switch scenes, all of your game objects are destroyed. Now, if I have my Realm controller inside of my sample scene right now, and I wish to use that Realm controller in another scene, well, what I would have to do is I would have to reestablish my connection with that Realm database. I mean, the connection is local, but you still have to open it. It could be resource intensive. What makes sense is to use a singleton that we're using the same instance regardless of where we are in our game. So to do that, what we're going to say is we're going to say static public Realm controller, and we're going to call it instance. Now we need to initialize it. So we're going to use the awake method. So we're going to say void awake. This is part of our Unity lifecycle events. I'm going to use this method. Don't destroy on load. So what we're saying here is do not destroy our Realm controller game object when we switch scenes. We do need this to be available all times, every time. And I'm going to pass in game object, which means that we're referencing the game object that this script is attached to. Perfect. So the next step is we're going to say instance equals this. And we're going to call it just for now. In order to continue working with Realm, so we have a Realm controller for working with it, but we need to define a data model. So what is our data going to look like inside of Realm? So going back into the Unity editor, we're going to create another script. So I'm going to right click, I'm going to say create, and I'm going to say C# script, and this is going to be game data model. And you can call it really whatever you want, doesn't matter. I'm going to double click it. Now this is not going to extend the mono behavior. We do not need the Unity lifecycle event. So what we need to do is we need to extend Realm. So this is going to be a Realm object. We don't need the Unity engine for this. Instead, we want to use realms. And we also want to use MongoDB. So we want to use mongodb.bson. We no longer have a start and an update to work with, which is fine. But we do want to define the fields in this game object, so within this Realm object. So starting with our primary key, because Realm does expect this. This is an object-oriented database, and it does expect a primary key, even if it's going to be used differently when it comes to MongoDB in the cloud. So we're going to say primary key as a property. We're going to say public. We're going to say string ID, and we're going to give it a getter and a setter method. And we're going to do the same thing for a few more of our variables. So we know that we probably want to store a score value. So we're going to say public int score. And you know what? Maybe we want to store the x and y value of our player too. So we're going to say float, and we're going to say x as well as y. Now this is going to change slightly as we progress, but this is a good starting point. And we don't need annotations yet for any of the other fields. So we have our data model to work with. Let's go back into the Realm controller. What we're going to need to do is we're going to need to import Realm again. So we're going to say using realms. And we need to add a variable to handle our currently open Realm instance. So we have an instance to our actual class. What we need to do is we need to get access to the Realm itself. So we're going to say private realm, and we're just going to say realm, and we're going to see if that realm already exists or not. So we're going to say if realm equals null, then let's go ahead and create a new one. So we're going to say realm equals, and we're going to say realm.getInstance. So that will get an instance of a new realm. Technically, if you already have a realm in your local file system, it will just get that, which is good, because if you already have a game established on Android or iOS or wherever it may be, you don't want to just create a new realm every single time. You just want to get a new instance of it. So we have that. What we want to do is we need to handle the circumstance where we stop our game. So we need to destroy it, not the database itself, but the instance of it. So what we can do is we can say void onDisable. And we can say if realm is not null, so it actually has something, we can say realm.dispose. So we can destroy it. All right, so we have that taken care of. Now let's go ahead and worry about either getting our data from the realm or creating data in it. So let's go ahead and create another method. And we're going to use this method as a helper method. And like I said, anything you see here, there are probably a million ways to accomplish the same thing. It's really your preference and your coding style. So what I'm going to say is I'm going to say private. I'm going to say this is going to be a game data model. And I'm going to say get or create game data. That's going to be the method. So I'm going to say game data model. And the actual character should not be capitalized in the variable itself, but I'm going to say equals, I'm going to say realm dot find. I'm going to tell it what type of data I'm finding. So it's going to be, we're going to be finding a game data model, and I'm going to provide it a primary key, which we know to be a string because that's what we've defined in our game data model class. Now, right now, nReboy doesn't exist. So what I'm going to say is if game data model equals null, so it doesn't exist, this is our first time trying to work with it, we're going to create it. Now we can work with our objects like C# objects. That's the point of an object-oriented database. However, to avoid problems when it comes to multi-threading and things like that, we do need to wrap it in a certain write block. We don't have to do that for reading, just writing, but that would look something like this. So realm.write, and within this write block, we're going to create it, and we're going to grab an instance of it. So we're going to say game data model equals, and we're going to say realm.add. We're going to say new game data model, and we're going to define the data that exists for this particular new game data model that we wish to add to our data store. So we have an ID. Let's go ahead and call it nReboy. We have a score. Let's go ahead and zero it out. We have a x value, so also 0, and a y of a 0. So we're basically just initializing everything, so that way we're good to go. And then outside of the if block, we're going to say return game data model. We're doing that because we've either found data or we've created it and we are returning what we just created. So life is good, and we're going to call this method every time we try to access our data, so that way we don't ever end up with null data values and things like that. You can have basically as much data as you want inside of your realm. In our case, we're only working with one piece of data because our primary key is always going to be nReboy in this example, but we're going to expand upon it in just a minute. But now that we have that, let's go ahead and make some changes, or additions in this case. So I'm going to say public, and I'm going to say int get score. So let's go ahead and get our data from this particular data store. So I'm going to say game data model equals get or create game data, and I'm going to return the score value. So I'm going to say return game data model dot score. So I'm just going to return it as is, because once we actually have our data, we can use it just like we would any other C# class. Let's go ahead and add another. I'm going to copy this. This time around, let's go ahead and get the position of our player. So I'm going to say vector2. I'm going to say get position, and technically we don't need to do it this way. We can just return the entire game data model to whatever class is requesting it. but I find that it's a little cleaner just to create helper methods along the way. So get position. We do have an x and y value, so what we have to do is we have to return a new vector2. So this is game data model .x and game data model .y, so a new vector. Let's continue creating new methods. So this time around, I'm going to say I want to set the score and I want to set the position. So I'm going to say, I'm going to paste that. For setting, we're going to say void. We're going to say, instead of set, let's go ahead and say increase score. I'm going to define maybe what I want to increase it by. So I'm going to provide it a value. This is where we have our write block. So I'm going to say realm.write. And within our write block, what we're going to say is we're going to say game data model dot score plus equals value. So we're going to just add value to whatever our score is. Let's do the same thing for our set position. So I have a void here for our function, and I have a set position. Our position, we're working with vectors, so let's go ahead and take in a vector. So we're going to say vector2 position. And let's use our write block once again. I'm going to copy it over. I'm going to paste it in. And for our position, we have our x, which is going to be position.x. And we have our game data model.y equals position.y. Because a vector, we have access to the x and y coordinates, and that's good enough. There's one more thing that we will need to do in the future, but for now, this should work out wonderful. So we have each of our methods. Let's go into our player.cs file, and this is where we're actually going to increase the score. But actually, before we do that, let's go back into our Unity editor. We need to actually link up the score so that way it can be shown visibly. So we're going to create another game object. It's going to be empty. This one's going to be responsible for controlling our game. So typically you would want something kind of like a superpower or whatnot. It's however you want to phrase it. Something to control all aspects of this particular scene. There's different ways to do that. I mean, technically I could have all of this information inside of the player game object or the incentive, but from a maintainability perspective, just go ahead and create a game controller. Doesn't need to persist. It's just for this scene. I'm going to create a new script. This is going to be a C# script. I'm going to call it game controller. I'm going to click on game controller in the sample scene, and I'm going to drag the script into the component section so that way it's linked up. And now I'm going to open it. All right, so inside of this game controller, we will be using the mono behavior. And what we want to do is we want to be able to control the score, so the text. Now to do that, we will need to import a new dependency here. So we're going to say using Unity engine.ui, and we're going to say serialize field private text score text. Now we're going to do this in a few functions here, so a few of these lifecycle hooks. So you'll notice that this is a little different. So even though that we're working with a component and whatnot, we're not going to try to grab it from the game controller because the game controller itself does not have the text component. This is going to be something else. So what we can say is, and you'll see what we do in just a moment, but what we can say is score text dot text equals score, and I'm just going to set this to 0. We're actually going to take it from our data store instead of the update. And the update happens so fast that you won't even see it as score 0 when we load our application. But we're going to say score text dot text equals score, and we're going to say plus realm controller dot instance dot get score. And because it is an integer, we do need to convert it to a string, so we can say to string. Now, if I were to run it, it would fail because score text, we have no idea what score text is. It's a serialized field. So let's go back into the Unity editor. Let's click on game controller. You'll notice that there's score text there because we're using a serialized field, but it's none. So go over to your sample scene, drag score text, not the canvas, just score text into that empty field. So now they are linked up. And if I were to hit run, it probably will still say 0, but as long as it doesn't have an error, we're good to go. So score 0, because we don't have an actual score value yet. It's just the initialized state. So let's go back into our editor, and let's go ahead and go to our player. Let's add another collision method here. So we have the collision information inside of incentive to tell us what the incentive should do after a collision. But let's go ahead and define what the player does after a collision. So we're going to say void on collision enter 2D. And when the player collides, and this could easily be added to the incentive if you prefer, but when the player collides with something, let's go ahead and say realm controller dot instance dot increase score, and we're going to increase it by 1. What we're also going to do is we're also going to save the position. So we're going to say realm controller dot instance dot set position. And this is a vector, and we have a rigid body, so we can just say rigid body 2D dot position. And this will pass through our position vector. So let's save it. Let's go ahead and go back into our game. I'm going to hit preview. And we have a 0 score. Let's go ahead and start hitting these. It increased pretty fast because it probably randomized on top of my player again. We don't have any logic to prevent that. But the score is increasing. If I stop it and I start it again, it should still say 6, I think. That's what we left off at. Yeah, so it says 7. I think that's probably what we left off at. You'll notice that it did center our object, so we're not actually updating the position. Let's go ahead and stop it. Let's go back into our editor for player. So when we start our game, so on the first frame, instead of setting it to 0, let's go ahead and say that we want to say realm controller dot instance dot get position. So that will update it to whatever we last saved it to. So if I went back into Unity, remember we did actually store the updated position. We just never updated it visually. So let's go ahead and save it. Let's go ahead and run it. It should update visually. Yeah, that's not centered, so that's good. If I were to try it again, it should be 8, and it should be up there again. And it is. So the actual incentive positions we don't care about. They're moving around. But everything is stored. We're persisting our data. So this is actually creating a data store on the device. So that could be my Mac, that could be my Android phone, my Nintendo Switch, whatever. And what we want to do now is we want to sync this data. So another cool feature of MongoDB, we want to be able to sync our data between MongoDB in the cloud and MongoDB locally. So MongoDB locally being our Unity game. So let's go into our web browser. We do need to set a few things up. So this is MongoDB Atlas. Everything that I show you can be accomplished on the free tier. So you don't even need to enter a credit card to sign up for an account. So I do have a cluster created. I'm going to say browse collections. This is my free tier cluster. I don't have a database for what we're about to do, so I'm going to say create database. I'm going to call it Tracy Devs. And for the collection, I'm going to call it game data. And I'm going to say create. Now if I scroll down, I have my database and I have my game data. It's empty. Now we could leave it as empty, but a cool tip that I want to give you is let's go ahead and add some sample data for what we want our data to look like, because it's going to be beneficial in the next step. So I'm going to say insert document. We do have an ID here. We're going to leave it because we're going to make some adjustments. We have a score. We have an X. We have a Y. We want to change these from string. So this is going to be an integer. And our X and Y, we can't choose float inside of the collection editor here. So we're going to choose double, next best thing. And finally, because we're going to be working with sync, we want to add another field called user ID. And this is just for this particular example. Yours may be different, but let's go ahead and call this sample. So we have our primary key is going to be this ID, our random hash, and our user ID, so that way we know where to sync our data to, is going to be our user ID. So I'm going to say insert. So let's make use of it. Let's go to the App Services tab. We're going to create a new app to play around with. I'm going to call it Tracy Devs. I'm going to make sure it uses my examples cluster, and I'm going to say create app service. All right, so we have an app service. Now there are a few steps that we need to do to enable sync. First of all, we need to go to schema. So inside of schema, search for that database and collection we just created, click it, and let's say generate schema. So this is where that sample document comes into play. We're going to say generate schema from sampling. We only have one document in there, but it was able to generate it based on what we have. Now we do have to make some minor adjustments still, but it did save us from having to type most of this in. So the title should actually match your collection name. So this, in my case, is called game data. The X is not a double, so we do have access to floats in the app services. So I'm going to say float for the X and the Y. We also need to define what are required, and in our case, everything is required. So we're going to say required. So we have ID, we have score, we have X and Y, and user ID. Doesn't really matter the order that you enter them in, as long as you've added them. And what I'm going to do is I'm going to scroll up and I'm going to say save. But I'm going to add a comma so that way it doesn't yell at me for an error. So I'm going to hit save. It's not deployed until I hit review and deploy draft, so I'm going to click it. Scroll down to hit deploy. So it's deployed. That's step one of our app services complete. So I'm going to click on authentication now. So to keep this app simple and easy to follow, we're not going to be worrying about username and password auth or OAuth or JWT. We're going to use anonymous authentication, which is fine. It's just going to create a new session every time you start your game, as long as you haven't cleared the previous session. So I'm going to say edit. I'm going to say enabled, and I'm going to deploy it when given the option. And realistically, I mean, I guess it depends on your game, but realistically, you probably wouldn't use this as your option in the game. The code itself in your game is going to be not much different. It's just a little easier to discuss through. So that's enabled. We have authentication. Let's go to device sync. This is where we're going to enable sync. I'm going to be using partition-based sync, which will partition based on a particular field, in this case the user ID, but you do have flexible sync as well, and you should definitely review the documentation to see which is best for you. I'm going to scroll down. I'm going to say examples as my cluster. The partition key is going to be my user ID. And I'm going to say that users should be able to read and write only their own data, not everyone else's. And it's going to create a rule for me. So I'm going to say enable sync. I'm going to say review and deploy the draft. And before we go back into our code, there's going to be one more thing that we look at. So we're going to look at the Realm SDKs. I'm going to click on Realm Object Models. And I'm going to click on C#. So it's going to give us a new object to work with. And you'll notice that it looks fairly similar to what we've already created. But there are some differences. So for example, our primary key is now an object ID. It is mapped to something. So we're actually defining what it's mapped to. Because when we're working with our local data properties and we're worrying about our remote data properties, we need to be able to link the two together. And they don't need to be named the same thing as long as you've defined the mapping reference. And case sensitivity does matter. So I'm going to copy it. I'm going to go back into Visual Studio Code. I'm going to go to my game data model, and I'm going to paste it in. Now, just as long as you pay attention to game data model, renaming it as such. So I'm going to save it. We do need to make a few adjustments here. So we're going to go into the Realm controller, and we need to actually connect, and we need to authenticate. And then after we authenticate, we need to either do a bidirectional sync or actually go into our application. So we're going to add a few more variables here, and we're going to import one thing. We're going to say using realms.sync. We're going to say private. We're going to say app is going to be Realm app. We're going to say private user. It's going to be Realm user. And we're also going to say one more thing. We're going to say serialized field. We're going to say private. We're going to say string Realm app ID. So this tells us which Realm app in the cloud or which app in the cloud is going to be what we're working with. So which app configuration. So let's go ahead and go back into our web browser. Let's copy that ID, scroll to the top of your app services. It's right here on the left. Click the copy button. It's not what you think it is. It's not just Tracy Devs. So I'm going to go back into my code. I'm going to paste it in. See, it's a little different. So let's get down to business here. Let's make some changes here. So first off, we do need to attempt to log into our application. And this is going to be an asynchronous event. So we do need to make this an asynchronous function. What we're going to say is the following. We're going to say realm app equals app.create. We're going to say new app configuration. And we're going to pass in the Realm app ID. Perfect. Next up, we want to see if we've already attempted to log in or not. Because if we've already logged in and our session is still valid, there's no sense slowing us down and logging in again. So we're going to say if realm app.currentUser equals null, so we're not logged in, then we're going to do something. Otherwise, we can copy a lot of what we've already done here. So if we're copying what we've already done, we already have a logged in user. We're going to say realm user equals, and we're going to say realm app.currentUser. We do need to change something on line 27 though, because we are working with sync. So the get instance is still the same, but we now have a parameter here. So we're going to say new partition sync configuration because we're using partition sync. We're going to say realm user.id. So that's the partition key. And for our user that we're going to use for our sync, we're just going to say realm user. So remember, user ID is actually our realm user ID. So that's what we're going to use. Now, if we haven't logged in yet, what we're going to say is we're going to say realm user equals await. So this is asynchronous login. We're going to say realm app.login async. Now we're going to say credentials.anonymous. If we were using email and password login, OAuth, JWT, the credentials would be slightly different. But we're going to use anonymous here. Next up, we're going to say realm equals await realm.get instance async. So this is an asynchronous initialization of our realm because we're logging in and we're making sure everything's good. We will copy everything from our other get instance statement, so our partition sync configuration, and we'll pass it in. So that's good. So now we have auth and set up for our remote realm. So we actually have sync capabilities as of now, but we need to make some adjustments. So if I scroll down to the get or create game data, our primary keys are not strings anymore. They're game objects, and we're doing things a little different. So before I start changing this, let's go ahead and make an import here. We're going to say using system.link. So link being what Microsoft offers for querying. So it's going to give us an API to work with. So I'm going to scroll back down to get or create game data. I'm going to make some changes here. So instead of realm.find, I'm going to say realm.all, and this is going to be game data model again. And we're going to say .where. So this is where we enter our query. We're going to say, I don't know, D for data, doesn't really matter. And we're going to say d.user_id equals, we're going to say realm user.id. And so as long as the user ID matches the realm user ID, then it's going to return data to us. And we're also going to say, because we don't want all, we just want one. There should only ever be one realistically. We're going to say first or default. Because we're working with user IDs now, we're no longer working with this ID. So we're going to say user ID equals, and we're going to say realm user.id. So just minor change there. Now there's going to be one more thing, and this may not occur in your game, but I'm telling you why we're going to consider it. So in most games, there are a login screen. You log into the game, it shows up a loading bar while it logs you in, and then once you're logged in, you can play the game. Because we're not showing a loading bar, Unity awake events, they happen in parallel. So we may try to render stuff on the screen before we've actually logged in, and we don't want that. We want to be sure that Realm is ready, and the easiest way to do that is with a login screen. But because we're not doing that, we can actually do something a little hacky. So I'm going to create another method. I'm going to say public, and I'm going to say bool is Realm ready. So we're just going to check to see if Realm is ready, and then if it is, great, we're going to use it. But again, this is hacky. There's other ways to do this. Ideally, you will have some kind of login screen. So I'm going to say return, and I'm going to say realm not equal to null. So if it's not equal to null, it'll be ready, it's true, otherwise it's false. So let's make some adjustments here. So let's go to our game controller. Let's wrap this in our is Realm ready. So if realm controller dot instance dot is Realm ready, then let's go ahead and try to use it. So that way we don't get errors. Because worst case scenario, it'll just say score 0. And let's copy this and add it elsewhere. So we know we're in the player.cs file. We're using it in here. So let's go ahead and add it there. It's basically everywhere where we're trying to use our Realm. And then finally down here. And I think that covers everything of where we're trying to access Realm. So if we save it and cross our fingers, everything should work great now. So let's go back into our game. And we're getting an error somewhere. So on line 26 of the Realm controller. So let's go back. So we have a missing semicolon. Let's go ahead and add it in. And let's go back into Unity. I'm going to hit play, and it's likely going to throw an error at you, and I'll explain what that means. Yeah, so it did throw an error, and it says score 0. So the error, I'll call it out here. So the error is actually invalid schema change. It's because our local game schema in the game data model does not match what we have remotely. This is for safety reasons. So what we're going to do, just because we don't want to add any kind of migration scripts to the workflow, I'm going to open up my terminal and I'm going to clear the local game database from my Mac. So I'm going to navigate into the library folder. It's going to be different depending on the platform you use. I'm going to go to application support, and because I have the default settings, I'm looking for default company. And I called it Tracy Dev Sample, so I'm going to say RM RF. I'm going to say Tracy Dev's Sample, and I'm just going to wipe it clean. So I have no local database as of now. I'm going to run it, and hopefully we get success. All right, so we still have an issue. So I'm pretty sure I know what that means. So remember, if we look at our code, our game data model, the class is called game data model. If I go to our web browser and I go to our schema, go to game data. I think I called it game data in mistake. So it's not the collection name. So the title is actually going to be our class name. So I'm going to save it. We will need to make some adjustments. So I saved it, review, draft, and deploy. I may need to restart sync. If not, great, but just take into consideration that it could be a thing. All right, successful. So I'm going to go back to Unity. Let's run it with the idea that maybe we will still run into problems. It looks like we might be good, so let's go play around. So I'm accumulating a score. I'm going to stop it. So I have score 3. I'm right there. It may collide when I start it up again, but let's see it. Still there. All good. Let's go into our MongoDB. Let's go to Atlas here. Let's click on Browse Collections. Let's scroll down to Tracy Dev's Game Data. And there you go. You have a record here that was created from our local game. Now, if I run it, let's go ahead and see what else we can do here. I'm going to click Run. I think we have 3 as our score. Perfect. It's still running. I'm going to go back to my web browser. I'm going to make an edit on this document. I'm going to change the score to 30. And I'm going to say update. It's updated there. If I go back into my game, it already synced for us. So we have two-way sync. So not bad. So I do want to do a recap. I know this was long. This is, like I said, this is what we went over at the Tracy Developer Meetup. I thought it was a good idea to go back and re-record it because I didn't record it at the event itself. So I regretted that. So let's see what we did. We created a few game objects, a Realm controller, a game controller. We demonstrated how to move these objects around, how to include physics. The bulk of our code was actually with our data persistence, so Realm. So we did create a data model. In this particular example, this model is linked up based on fields to our remote MongoDB Atlas collection and the fields that we would see in our documents. The Realm controller, we're authenticating with anonymous authentication here. We are asynchronously getting our instance with a partition sync configuration. We have our very basic classes or not our classes, but our methods for creating data or getting it if it exists. And really the sync and the data stuff happens in the background. This is an object-oriented database, so we work with our objects as they are with the exception of the right block. But other than that, you get to work with Unity in its entirety and then just kind of treat Realm and data as an afterthought once you start creating all these helper methods and stuff. So not bad. Once again, I am the Tracy Developer Meetup organizer in Tracy, California. I encourage everyone, doesn't matter your age, this is a family-friendly group. I encourage everyone to come and participate. I am also a developer advocate at MongoDB, hence why we chose to see some stuff on MongoDB and Unity. But everyone can get involved. It's a lot of fun. Unity is a lot of fun. And it's a great way to get into game development or just development in general if this is your first avenue into development, because it takes a more funner approach to things and it makes learning a little bit more fun. So if you like this video, hit that like button, subscribe to the YouTube channel, drop a comment, let me know your thoughts. Until next time, everyone, have a great rest of your day.